Welcome back to You Revise, where we talk about everything exams. Let us take a look at question 41C from the 2016 exam. It reads nitrogen dioxide is toxic to humans when inhaled and is a significant component of air pollution. It can be formed by the combustion of nitrogen in the air at a high temperature, firstly forming nitric oxide and on further oxidation forming nitrogen dioxide. The overall equation for this process is given here. We've got this overall process given here. The following questions relate to the equilibrium system represented by the equation. So the question goes on to read, on the axis below, draw the forward and reverse reaction rates starting at the moment when oxygen and nitrogen gas begin to react with each other until after equilibrium has been established at A. Continue the graph until time B. On the same axis above, draw and label clearly the effect of conducting the same reaction at a higher temperature. Let's take a look at what the examiner had to say about this one here before we just break down the question and do a lot more with it. Probably we'll be doing some breakdowns as we go, analyzing the examiner's report. It says many candidates fail to label either graph resulting in a loss of marks, graphing skills in general. So what does this first part mean here? Let's actually, when you draw a graph, let's say I've got two lines on my graph. I've got line A and another line B. It doesn't matter what graph I'm drawing. This is my line graph. I don't know what that means, but I'm just drawing to say I've got this A and B. This, let's say it's representing cats, and this is the graph that represents dogs. You need to label these lines so that whoever is marking your exam would know what each of those lines mean. That's what the examiner, or you can have a legend on the side here where you go, this is cats, and then the bold line, exactly as the examiner tells you here. And if there's more than one experiment drawn on the same axis, you should also clearly label which graphs are representing the first experiment, second or third experiment. Your graph should communicate a lot because, like they say, a picture says 1,000 words. But if that picture is not clearly labeled, it's gonna say no words at all. So that defeats the whole purpose of drawing a graph. The word graph just means picture, okay? So let's move on. Graphing skills in general were poor. Probably this examiner is talking about me. I don't like drawing, but anyway. Curved lines were not smooth, which is very difficult, and straight lines were not straight. This should be a walk in the park because you know what? Civilization invented something called a ruler, where you're supposed to draw a straight line, use a ruler. It's so much frustrating from a perspective from a teacher perspective, where a kid has a ruler right next to them. They decide to use to draw a straight line using just like, freehand. That doesn't work. I understand curved lines because we've got different motor skills. Now, were not straight and horizontal. Many candidates did not demonstrate a strategy to plan and draw curves. Now, this is my strategy for drawing curves. Let's say I want to draw a curve that goes from this point and all the way ends here, but it passes through that point. What I do is I just try to, start off by drawing some dotted lines and then carry on until to the point. And I said, no, this is not quite like it because I'm using a pencil. This is another thing. I see students who I've got a pen, it can write on a piece of paper, I can use it for drawing. That's why we insist on using a pencil, because if I don't like this, I can go on and say, okay, civilization invented the rubber. I don't like this part actually. The other parts look okay. Let me try and just change this part. I can easily change that. My curve is looking much better, and I can complete that. If I want to have this as a a bold line. I can now go over it to try and make the curve as smooth as I can get it. Okay, that's my strategy. You can develop your own strategy that works for you, but sometimes do not reinvent the wheel. If we've got tools that have been invented for certain tasks, use that tool. Let's move on. And some displayed a poor understanding of what was happening within the system. So obviously when you change pressure, temperature, etc., now that's theory, trying to imagine and visualize what's going on so that it can replicate that on paper, on the graph. Part C1 and Part C2 were difficult to mark as many candidates did not indicate clearly the higher temperature graph distinct from the lower temperature one, which is what I was saying earlier here when I was giving this example, to say if you've got more than one experiment to display on the same graph, right? You've got more than one experiment. These are all lines. You need to say, okay, this is experiment 1. These two graphs are representing experiment 2. Find a way of communicating that in a way that whoever is marking your work doesn't have to figure out, okay, which one is this? Now, Part C1, the main errors were two curves did not meet at a point and the horizontal lines drawn apart from each other. Now, for this graph here, the general shape you were supposed to get would look something like this. Let me get rid of this mess here. So if you've got a system and you're displaying the rate of reaction, we know that when a system reaches equilibrium, according to these two reversible arrows here, the forward reaction and reverse reaction are occurring at the same rate. And this y-axis represents rate. If the rate at the end of the reaction is now, let's say, this one here, all my graphs must converge at this rate here. This one might start from the top all the way down here, and another one might come up like that, and then, but they must all converge at the same point, because this is where we are saying equilibrium has been established. This is what the examiner is saying here. Let's look at the next part. Many candidates failed to commence the reverse reaction at 0. Where is the information in the question telling us to commence this at 0? It's here. It's implied in the question. Okay. Reaction rate starting on the axis below. Draw the forward and reverse rates, right? Starting at the moment when oxygen and nitrogen begin to react. So this implies that there was no nitrogen dioxide, and nitrogen dioxide was only produced after nitrogen and oxygen began to react. Now, Part C, candidates failed to show that equilibrium would be reached earlier, and although the graph indicated that rates would be higher. So when you increase temperature, it means you are increasing the rate of reaction. So if a reaction is occurring faster, it's going to reach equilibrium much quicker. Let's say this system reaches equilibrium here. If I increase temperature, I expect equilibrium to be reached much earlier at some point. There is no specific point, but as long you are showing that this system at lower temperature is reaching equilibrium at a later point, but the one at a higher temperature is reaching equilibrium at a what? At an earlier point here. That's what the examiner is saying. Obviously, these graphs are higher and higher to show that the rate is increasing. We're going to look at that in detail when we actually tackle the question and give you the proper answer. Right. I think that is what I want to say here. Let's look at the syllabus points that were being examined here. We've got this one which says understand the characteristic of equilibrium systems and explain and predict how they are affected by changes in temperature, concentration, and pressure. Here we're not supposed to explain. We're just supposed to predict and illustrate that on a graph. Okay, so we are looking at, okay, if I increase temperature, the rate is going to be higher. So how do I illustrate that, and how do I show that, or how do I show that using the graph? Okay, now let's move on and actually look at the actual solution we were supposed to present to the that was supposed to be presented to the examiner here. With the examiner's report out of the way now, let's focus on what the answers should have been, or how we should have drawn these graphs. Part C1 reads, on the axis below, draw the forward and reverse reaction rates starting at the moment the oxygen and nitrogen gases begin to react with each other until after equilibrium has been established in part A. Continue the graph until time B. Now I've cheated a little. I don't think it's cheating because I've got the tools. I'm using the tools. So let's just agree that I did the right thing. I used the tools. I've drawn my straight lines, which are horizontal, yeah, and straight like the examiner wants them to be. Now let's look at what's actually happening within the system. This is what's happening. I mixed two gases here, nitrogen, and I've got oxygen. Right. It doesn't matter the concentration of nitrogen. The concentration or partial pressure of nitrogen might be higher than the concentration or partial pressure of oxygen. But what I definitely know from this is I've got a lot more collisions on the reactant side than on the products. Why? Because the reactions at time 1 or time 0, like here, right at the start, at the initial time, it's higher on this side, and on this side it's 0. As these collide, the collisions on this side will also start to build up, and the collisions of this, as the reactants are being consumed, the collisions on the reactant side will also start going down. But now, what most of my students tend to do here is they think, okay, because I've got nitrogen and oxygen, I must be drawing two separate graphs. No, for rate time graphs, we are looking at the rate, so we are combining. We're just looking at collisions. Which side has got a lot more collisions? So in this case here, the forward reaction, which must be drawn with this solid line, starts up with a higher rate of reaction, which I could put maybe somewhere around there. Okay, and then this one starts with a lower rate. Let me lower that a little bit, because it doesn't have to be too close to this. I can start it at round about here. And then this one starts at 0. Okay, when this happens, we know that, like I said, I prefer to use dotted lines before I do the solid line. So I'm gonna look at this to see if it works out for me. No, probably not. I want to try and do it this way, right up here. As long as I'm starting this at a higher rate, that's fine. I can get rid of this. So I've got a rough idea of the where I want to place my graph. So I can go in now and draw a solid line. Right. I need to get rid of this one here to keep this smooth. Oh no, I made a mistake. Now again, draw a solid line that comes straight, solid curve, not line, because it's a line, curved line. That's what I want to say. For some reason in my head I'm thinking line just means straight line. That's stupid. I'll try again. Let's do the dotted line. Go back to the strategy. If you have got a strategy, use it. And then I put my solid line in place to go like that. No. I can see this is not easy. If it was on paper, it wouldn't be really hard, but doing it on the computer here, it's not as easy as I thought it would be. Like, let's go on and do this. I'll keep trying. eventually I'll get it. I know. It needs to win so many times. I only need to succeed once, like I've done there. Now I've succeeded. You just need to be careful getting rid of these dotted lines I've put here. But otherwise that looks better now. I'll leave that one. And I do the same with this one here, drawing dotted lines and making it into a curve like that. This is not gonna be a problem because once I get the dotted lines, this works. Okay, I know that took me a fair amount of time, which is probably what it should take you if you want these 3 marks. Yeah, okay, and this is what this should look like. Yeah, I mean, stop tinkering. I might end up with removing that. So that's the first graph. So this one is going to be lower temperature. I label this lower temperature. This is also the lower temperature graph. I have to label these. Now, according to what the examiner says, it was a problem. Now, I'm going to draw another one now for the higher temperature. How do I know where to draw this graph? Because when I increase temperature, I'm going to increase collisions, like I said, and earlier on in this video. So I'm going to draw this. It's going to be higher, and it is establishing equilibrium earlier on. Yeah, you can see here equilibrium is establishing at A. This one, equilibrium is establishing somewhere before A, to show that it's a higher temperature. And then I am going to draw a solid line. This was easy, right? So I'm going to label this higher temperature. Let's look at my labeling here. It's not the best because it's showing lower temperature for that one. I need to label this lower temperature, and this one is the higher temperature graph. So that way whoever is marking would know what's going on. And that is what we were supposed to be doing for this question. As you can see, the drawing of the graph hasn't been easy, especially if you're doing it on a computer. I know on paper it's relatively easy. Okay, now I'm going to finish off this one here, and I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.